So hi everyone. Hi, my name is Kigen Tembu. I'll be leading you guys through the first part of this training, which is basic training. So don't worry if you've never seen R, you've never done any data analysis before, don't worry. It will be as bare bones as we can. So, and don't be afraid to speak up if you don't understand something. We are supposed to build a warm, welcoming environment, culture, that everyone is free to speak out any questions. So the point of this exercise is to introduce you to R in the most friendly manner possible, so that you can be... I'll have to use the mic, huh? Yeah, so the point of this exercise is to get you started, and hopefully you can move on from yourself. Just putting a seed for you to start this learning about R and how it can use you. So just by spreadsheet users, people who use Excel on a day-to-day basis. R users, I think there are a couple, few. Python users. Okay. Spreadsheet users, there's none of you use spreadsheets at all. Most of you use spreadsheet. No, I'm wondering for the rest about them. A bit about myself and my journey with R. So I did my undergrad in statistics in University of Nairobi. We just went through the basics of R, not really the best for learning or using it. So when I came to the workplace, it was another learning curve. So, and the tool that I encountered the first was spreadsheets. Then you reach a point you realize spreadsheets are not enough, or they're not efficient. So you move to I would call this higher level of analysis, or one that can push or superpower your analysis. So I started getting into R. It was really hard at the first time, yeah, really, because I started with R, and then when I went to Python, I realized Python is so much easier. The syntax is so much easier. The error messages are so much easier. But yeah, so that's one you could say Python has over us, is it's a bit easier to learn. The syntax is easy. Yeah, the community, I think Shell mentioned a bit of this. So the community is a bit better. So my inspiration to give this talk was basically to see people have an easier route than the route I used to learn R. So you wonder why you'd use software. So there's this quote from this guy. It's called Naval Ravikant. He's on Twitter. You can follow him. He's a very active venture capitalist, software developer. So he says computers are the most powerful tool ever created by humanity. I agree with most of what he says, but I'll give you an example of why. 10 years ago, say you wanted to analyze 200 data points. You could do it manually, or you could use a computer. A person with a computer can easily beat you. Like, it's like bringing a knife to a gunfight, basically, because that someone is really efficient and fast. So really, I would encourage you, I think most of you are into computers and stuff, but this is where the future is, and this is where a lot of the future world is going to be powered through computers. So if you learn this, it's a very big skill. So R, I'll start with the history of R. So it started with an S. So you might wonder, how many of you wonder why it's called R? Have any idea why it's called R? So there's these two guys, it's called Ross Ihaka and Robert Gentleman. So they were both professors at the time. This is in 1992, I think so. So R, actually last year they were celebrating 25 years of it being called R. So this guy, the one was in Canada, the other one was in New Zealand. So he flew over to New Zealand just for a 3-month lecture, just an engagement. And then he met this guy, Robert Gentleman. And they decided to form, there was already a language before R that was called S. So why it's called R is in memory of these two guys. They decided to name it R because both their names start with Robert and Ross. And as a, what would you call it? As a tribute to S, because it was based on S. So this is just a bit of the story where, so the interesting thing I didn't know about this before I made this talk was there was an initial concept of making it commercial, but it's open source right now. So at least, thank God they didn't make it commercial. So the first stable version was released in 1995. This was accessible to all the public at that time, but it was in hidden circles between 1992. So 1997, something called CRAN. CRAN means Comprehensive R Archive Network was built. So this is basically a set of the base, you could call it base of R, the initial packages, the functions, and the mathematical functions, statistical functions was built. And so there are a set of users who maintain this, who have the keys basically. I think in Python there was a similar story. The founder, I think, stepped down last year. So R stayed relatively unknown in the 90s till the early 2000s. So that's when data science started picking up in developed countries. So I think in Kenya it started picking up 2010 from there. So that was what was before. So I don't know how many of you know this guy. He's also a New Zealander actually, and he's not the only one who considers the future of R has really moved us from. So I could talk about the initial syntax of R was really not user-friendly. So you'd find some weird functions. There's a comma here, there's a semicolon here. But so there's something called the tidyverse, which I would encourage you moving forward to use in your any task that you would want to complete using R. So this guy contributed about 114 packages, which is a lot, really, really a lot. So you might wonder, well, what are the stuff that R has built? So I'll just move you to my web browser. So that link goes to this. In R, there's something called Shiny. It's basically how you can build web applications using R. R is evolving into a full stack language. That's what I would say. The future where it's going to full stack. So most of the functionality of other general purpose languages would be transferred to Shiny. So I'll just show you one of this interesting. So this is called a bus data dashboard. So can you imagine this as a map of something you can relate with, maps of, say, Nairobi and Matatu routes. So this dashboard could be used to find which buses are using which routes. So this was applied, I think, in a different country. I think it's the States, but yeah. So you could move to route here and say 10, and then it automatically changes. You could remove the check boxes westbound, so you back. So this is all of this has been built in R. So you can put a refresh interval. So this is some of the cool things that Shiny basically does about companies that use R. Airbnb uses R. Uber, I think, uses R. BBC recently, when they're making their graphics, when you see those graphs in their news channels, in their studios, it's all using R. Most of them, they powered it using ggplot. I think Shell has mentioned ggplot. So this just to encourage you that there's some cool things you can build in R, and hopefully get you interested in thinking about a problem that you have that you want to solve, and R can build that. So why R? Why R? Like, this is basically to the functionality. If I was to give reasons of why I'd use R over any other language, ggplot is the plotting visualization package in R. So it's really, 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 really powerful. Even Python users admit that ggplot is better than matplotlib. So that's the advantage it has. In terms of statistical libraries, there are lots. I can't keep count of them. Lots and lots and lots of statistical libraries. So if you have a problem that you want to solve statistically or use some statistical sets of tests, I would advise you to use R. The third one is probably the most important, I think. So it has an awesome online community. So if you're on Twitter, mostly on Twitter, just search the hashtag #RStats. People are very helpful. They are not trolls. I've not seen any trolls so far. They ask questions. There's screencasts. There is also a hashtag called Tidy Tuesday. I would recommend everyone to check it out, Tidy Tuesday. So every Tuesday, if you're looking into getting into practice data sets, there's a community called R for Data Science, R for DS. So they post a data set, and then people get involved and send your GIFs or your JPEGs and your photos and everything. And you can actually see people open source their code. So if you see a cool plot with dark theme and everything, you can look at their GitHub and basically get their code and see, oh, this is how it's done, this is how it's... Personally, for me, there was a time I was using SAS for like a year. So that's what kept me... I was using it for work. But what kept me up to date in R is that Tidy Tuesday hashtag. So please get involved. And then, so spreadsheet users, I don't know whether you've had a problem with in the science, what I would call about the science part of data is science has to be, if someone else runs the same analysis, he needs to get the same results. So the science part in analysis has to be done with code. Because if I send you a piece of code and you run it and use the same data and they get the same results, then I can call that reproducible. So spreadsheets don't have the reproducibility part, at least at the basic level. So you can't really, okay, fine, I ran some function and this and averaged, but you can't really give it in a scientific basis. So why I would encourage someone thinking of getting into data science to focus on code is the science part. It requires you to be reproducible. You can share your results. A journal can even come and investigate your results and ask for the code base, and you'll be okay with it. So in this part, I hope most of you have installed RStudio or R. True? Anyone who's not installed, we give him some time or some time. So you can open your RStudio session. Then I can just briefly explain to you which side, how it looks. I think you've opened yours. Oh. Sorry, mine has a dark theme. I can show you how to change your dark theme if you like dark themes also. So, yeah, okay, it's a bit, so there are 4 pens. So if you're cooking, this is your recipe. So this is where you write your recipe down. I need 2 spoons, 2 teaspoons and everything. So you write and save your recipes here so that R knows what to cook. So yeah, this is the first part. Let me just show you. So this is my R session. Sorry, there are a bit of scripts there I have not saved. It's really bad behavior. So, but if you can go over to the file section. So this is just like any other Excel. So you can have a new file. I'll tell you what a project is and why you should use projects. So you can open a file, you can look at recent files, you can open projects. I'll tell you what a project is. You can also import a data set. This is the click and drag method of importing a data set. So you can import from Excel, SPSS, SAS, starter, from text. Then you can save your script from there. Okay, this, you don't need to know that at the moment. There's something called neat documents. This is more to do with R Markdown, so don't worry about it at the first point. Then you can print, you can close all except current. So edit again, most of this has the cut option, copy, paste, undo, redo, back. I'm not too sure what back does, but so you can go to a specific line. You can find a specific phrase in your code base that you might want to change. You can find next, find previous. You can clear the console from there. For the code section, you can insert a section. If you're in your code and you want to insert a certain phrase or a certain code that you want inserted, so you can do that. You can jump to file, functions. I'll tell you also what functions are. So you can extract a function, a variable, rename in scope. Most of this, over time, as you start using R, you'll get to know them, or you'll get to understand why they're doing. So there's re-indent lines. If you want to organize your code into a good manner, you can reformat code. This is the terminal. So view, this more to do with your viewing capabilities. If you want to zoom in, you can zoom in, click zoom in. So if you want to change your theme, I'll just show you the trick. You go to tools, global options, appearance, then now I want to change back to the white one so people can see. So classic. Think that's better for everyone? Yes, no?
Yes.
So yeah, I was just describing the top taskbar. I think we've covered up to plots. So for plots, if you're plotting, most of your plots will come to this section here. So where your plots will be seen, or where you probably view your plots. So if you have a couple of plots that you've been running in your script and you want to navigate from the first to the last, you put next plot. Because I haven't run any, it's grayed out. So next plot, previous plot, zoom plots. You can save as an image, save as a PDF, copy to your clipboard. You can remove the plot. So this is, the session is more to do with your R session. So when it's up and running right now, we're in a current R session. So if you want a new session, maybe you've crashed out or you've run an infinite loop that you're seeing maybe your R Studio is slowing up. You can just go to and you can restart on R, actually, yes. So there's something about it's called a working directory, but I'll tell you later on. This is just to go through the user interface. So build, configure tools. You don't need to bother too much with this at the moment. Debugging, so debug this for the part of debugging your code. So there are several methods of debugging code in R. There's something called a breakpoint, so you can insert breakpoints in your code. Basically, if you suspect your code is throwing up errors because of a particular section, you can go to that line and put a breakpoint. So you see the results before that and just confirm that this is where the error is throwing up. Profiles, yeah, you don't need to bother too much with this also. Tools. So there's something in R called packages. For other software users, you think of this as, for say, Python users, libraries, or yes, so I think they're still referred to as libraries in other languages. So for Python, you think of this as pandas. Pandas is a pack, you think what's referred to is as packages here. For spreadsheet users, I think they're extensions to Excel. So KU tools or something, you think of this as something that you can use to extend your code, you extend your functionality of your code. So how to get help? This is how to get help. So one of the things that is when I started learning out, well, that I didn't have a lot was how to find help, how to Google basically error messages. And I'll tell you for sure, R gives you some error messages you can't understand. Some base R functions, the tidyverse has really improved error messages, but can throw you up error messages that you don't understand or can easily understand. So in such cases, I'll show you a couple of ways which you can get help for such error messages. So RStudio, best thing about this thing, it has cheat sheets. So if you are interested in the IDE itself, you can click on it and it goes to a link, and you can download the cheat sheet and get just a brief overview of the key functions and what they do and what it's supposed to complete. So there are a couple of here. If you moving on in your R life, you'll probably use dplyr. It's called dplyr. ggplot2. dplyr is more to do with how do you wrangle your data? How do you have a set of dirty data that you want to clean and present in a way. So that's what dplyr does best, I think. ggplot, visualizing your data. You can do package development. You don't need to bother with that at the moment. Web applications with Shiny. I just showed you an app with Shiny. Sparklier. So some of the challenges you'll encounter moving forward in your data analytics path or problems you might encounter is you might have a CSV of the size. Okay, a CSV means comma separated file or a data file. Basically, that's 2 GB. If you try and read it in R using regular packages, it might be really slow. So Sparklier comes in for big, that's what we call big data. So yes, for spreadsheet users, I think the limit is 1 million for Excel, 1 million rows by 1 million columns. So you might reach those limits and you might look for other alternatives. Yes, I think R Markdown, as Shell has explained, is a beautiful way of expressing your code. Like, you don't need to transfer what you've done here to a professional setting. So you can write PDFs, Word documents, PowerPoint presentations from R Markdown. So basically your code is here, everything is centralized. So when you just run the code, it produces the final document. So I think that's the top section. So for here, you can, these are the options here. You can start a new script. There's something called notebooks. There's another called markdowns, which we've talked about. There is the good thing about RStudio is, if I click on Shiny Web App and say I give it a name, test, it gives you the outline. Basically, it does the basic work of some of the functions that you need to call, some of the libraries you need to call. So you just focus on your particular problem. So I find this really, 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 really neat. So again, this goes for all these options. Even for a markdown, it will give you. I haven't used the rest of this. Presentation, you can make a presentation. And then documentation. You can document basically what you've been doing. So this, your files will appear like this. Sorry, I haven't saved mine. So that's why it's called Untitled 3, Untitled 4, Untitled 6. They really, I don't know whether this is a cool thing, but if my art session closes and I open up, it will still be called Untitled 3 and the file will be there. But it's not good practice. I do not encourage that. But it's something of a bad habit. So that's the first pane. The second, for this part, so there's something what we call environment. If you're a software dev, I think you'd know what an environment is, but for other, say, spreadsheet users, so the best analogy that I would give is, if you have an environment, okay, most of the time you'll be operating the global, and if you have functions, you'll have a local environment. So and that's why this is called global environment. Yes. So it's where your variables that you've called, or your for functions, if variables go inside a function. So how R works is, if you've defined a function, let's assume for spreadsheet users, let's say a macro or something. If a variable is called within that function, what R does is it searches, first of all, inside that function, whether it's been called, whether it exists there. Then, if it's not there, it moves to the global environment and searches whether that variable is there. So that's basically what an environment would mean. And then for history pen, this is where you can see where you run your code, which are the most recent code that you've written. Yes, being told to hurry up. Connections. So for our users, you can connect to a DB, that's a database. If you have a database directly from here. So this is the more click and drag method, I guess. You can add a new connection. And then there are a couple of options that are served from there, from the existing data sources. So this section, the most important section for this section I would advise is, let's go to packages. Again, this is the extensions that people have made there, and it's open source that you can use to help you solve your problem. So most of the times you will find libraries that are there. You can manually tick them if you want, if the code you use there requires them. And it will load them up, as you can see from the console down here. So the console, is where, okay, this, you can't say this, but the console is where, again, we say the first part, this is where you write your recipe. The console is where the cooking happens. So this is where your code is run. And if you're looking for error messages, you look here. So you can easily, again, see whatever. If you've run something that's not, you'll see an error message there. All right, I think that's the basic introduction to RStudio and the interface. Anyone has any questions, clarifications that you want to use? So we talked about projects. The best way to run an analysis in RStudio is to create a project. So you go to the option. I'll tell you why it's the best way. New project. So there's something called a working directory. So you think of this as if you want to read a file, an Excel sheet, a CSV, a directory is where those files should be. So previously there was a function called set WD brackets, set working directory. But when it's not really good practice to use set working directory, because you can easily get mixed up. So say this is. Oh, and the awesome thing is most of you know about, I don't know, if code versioning or Git. You'll encounter this somewhere in your data analytics part. So the advantages of version control is you can reverse back changes. So if I made a change to my code and then I realized later on it has a bug and I want to go back. So most of the times we use GitHub basically. You can create a GitHub account and link directly to your project so that any changes you can merge, you can track basically any change that was made. This is very good if you are collaborating on a project with several people and you want to track who made these changes and if you can go back to those. So I think for spreadsheet users is you save files under version 1.1, 1.2, 1.3 that way. But you can think of this as a better way of version. So now here we are at a project called test. You can have several number of scripts. So assume this is a project that you are doing, a data analytics project. You can have several scripts inside this project, and you can have those files that you require in this project saved in a singular place, so that you don't have the problem of having a working directory with multiple files in different places jumbled up. Basically, it makes you organized. So I would advise anyone to always start with a new project. So I think that covers for R Studio. If you have any further questions, you can, further clarifications, you can come up to me later or after the meet, because we're running out of time. So, sorry. How was the temperature this week for you guys? I don't know, for me it's been really cold. How was it? It was okay, yeah? So, the data that I want to use today is for temperatures in Nairobi for the past week. So this is from Friday to last Friday, yes. So in between there was a 16 degrees and a 15 degrees. So think of this as the base, but what if you had a year's worth of temperature data? Would you use, you can manually analyze this string of data, but if you had 200, 1,000 pieces, you need to go to a software. So let's start with the basics, what you can do in R. For this, you can open your R sessions, which you've already opened. So this just explains the symbols of what you do. Addition is the normal plus. Subtraction is the normal minus. I think there's a minus. If exponential means, if you want to say 2 raised to power of 2, it's, you write 2, then the exponential mark 2. Division is the normal backslash. Modulo operator, so this is, for those who don't know this, it's, if you want to find the remainder, say if you have 3 divided by 2, what's the remainder of that? It's 1, yeah? So if you do that operation, it will, if you do 3 modulo operator 2, it will give you the result as 1. So integer division, for this is a very useful shortcut. Sometimes when you're plotting data and you have data from 1960 to 2000, and you look at the plot and you think it's better if it's expressed in decades. So you want the 60s and you want the 70s, and the 80s. So this is a trick I use personally, is integer division. So basically what it does is, say for 202 divided by 10, it only gives you 20. It only gives you the integer part of that division. So 202 divided by 20 is 20.2, but now it will give you 20. Yes, yes. So then there's what we call relation operators, which is less than, greater than. So those are the symbols. And then less than or equal, greater than or equal, then equal signs. So, and then there's a not equal. If you want to say 2 is not equal to 3, you can test this out in your console. 2 is not equal to 3. It will give you a result of, I think, true. So there's something in R to call vectors. The vector is the basic broken down, basic data structure, I would call. So if you want to put a vector, say our temperatures, you want to express it in a vector. So this is the name of the variable that you put. So example, this should be, say, temp. You can call it temperature Nairobi. Then there is this operator, this arrow, basically. And then you put a C. The C means concatenate. Concatenate means these pieces of data, I want it expressed in one. So if you do C, 10, 15, 20. So the C stands for concatenate. So you'll have a variable in your environment, you can test this out, called X. And if you call X, or you just write X on the console and click on it, it will give you the values that you've just inputted. Yes. Yeah.
So as he shows us stuff there, I know we are supposed to be coding later, but you can just easily type what is on the presentation and see the results. So that, and just in case you have a question, please ask us. But please type. Start typing stuff.
Yeah. So the best point I would advise, if you're typing on RStudio, type on the console part. That's the down part. And then after you finish a statement, just press enter. So we have, say, these two vectors. So this is what we call a vector, and this is a vector. So vectors, what do you think is the length? If by length it would mean how many elements are in this variable. So the length for this is 3, I guess, yeah? 3. So you can do operations on these pieces of data. So assume you have data of temperatures this week and temperatures last week, and you want to add the 2 or minus the 2. You would get those 2 variables and then add, just simply add them. If you add them in your console, it will add. So if you add this and this and this and this and this and this, it will add according to the position of the element. So this is position 1, 2, 3. So another key feature of R is it's one-based indexing. I think Python users have 0. So we start from 0, 1, 2, but for us it's 1, 2, 3. So if you're referring to this element, it's 1, 2, 3. So if you add this, simply these 2 statements, you'll get a vector of 15, 25, 50. If you want to check whether X is greater than Y, again, it checks element-wise. It checks element-wise. So it will give you a result. Again, the same length, but so for example, is 10 greater than 5? Yes. So the output here would be true. Is 15 greater than 10? Yes. So the output here would be true. 20 greater than 30? False. So it will give you a vector called true, true, false. If you try it out. On? the subtraction. Do you have this in your environment, x and y? If you've written these two and addition, how R adds these two things is it goes by position. So assume these are equal length. So this is 3 and this is 3. So it adds 10 to 5 becomes 15. 15 to 10 becomes 25. 20 to 30, it becomes 50. So you'll have a resulting vector with 15, 25, and 50. Yes. The next one. So if you are checking for this operator, again, this is a relational operator. So x is greater than y. So it will check again the x. The first element is 10. Is it greater than 5? Yes. So you will have an output of true. True. So they are logical operators, true or false. So if you're checking a condition, it gives you a result of whether it's true or false. Yes. So 15 and 10 will be true. Will be false. Yeah, because 20 is less than 30. Yeah. So this is just the basic operations, how you can do operations on a vector. So an interesting behavior on R is probably, you can think about it later on, but what do you think happens when you add vectors that are not of the same length? Length being the number of elements. So you have 5, 10, and 9, 4, and then you add 5, 10. Yeah. Yes. You type x, you've x greater than y. Has it given you the result? So this is an interesting brain teaser that you can think about. If you add these two, how R behaves. So basically, if you have an unequal length of variables, so this are say 4 and this is 2. If the length of one of the variables is a multiple, but a multiple is 4 is divisible by 2. So it's a multiple of this. So what it does, R does, it assumes the next one as 5, 10. So you'll have B, it will assume in the computation is 5, 10, 5, 10. And then it will add now A and B, respectively of just how we've added. So when you try this with something that's not a multiple, this is 4 variables, 4 elements, and this is 3 elements. If you try and add these two, A and D, it will give you an error because it can't replicate if you replicate this to the same length. Yeah. So logical operators. So this is for more to check logic. Basically, logic is, how would I explain logic? Checking conditions. Say if I give a condition, I'm from Kenya, it should give either true or false. Yes.
In the previous part.
Yes.
What if they were two? What if D was, they were two, okay, not 3, not 5, 10, and 8.
Yes.
But they were like 3 and 7.
So D, you want it to be how many? Yeah.
Dimensions are different. So you see D smaller
than D, yes. So it for this R checks whether it's a multiple. So it checks if one of the length is the number of elements. So if the length of say D is 7, and you have A is 2. So 7 is not divisible by 2 exactly. So it's not a multiple. So it will give you an error. it will give you an error. So for logical operators, if you want to check something as not, I'll show you how to check not. This is the symbol, basically an exclamation mark, yeah. And then and, if you have, I am from Kenya and I'm at the meetup, and the and part, if you have two conditions, say you're checking in your code, this is the symbol. This is called ampersand, I think, actually, yes. So ampersand, there are two ampersands. There's the one where you have one ampersand, and there's another where you have two ampersands. So I'll show you the difference in that, just I think the next slide will explain this. Then for or, if you want to check a condition or, so I am 5'6" and or I'm less than 5'10". So again, this is the symbol, just I think there's a straight slash, and then there's the double slash. This for logical R. I explained to you element wise, and I explained to you logical. So again, a feature about vectors, you can't have more than two data types in one vector. So you can't have a number and then have, say for temperatures, you can't have 21 and then have Wednesday in quotes. You can't have, it will give you an error. So they're what we call homogeneous. So it has to be a singular data type. So why this works is because false is considered as 0 mathematically, and any other true is considered as 1. So you can try and run this code. This is the not operator.